Hi, I'm Bob. Welcome back to our tutorial on how to solve the exercises for the textbook Microeconomics Theory and Applications with Calculus, the 5th edition. Today, we will continue to solve the exercises for the Sequential Dynamic Game section. Here's exercise 3.8. Levi Strauss and Wrangler are planning new generation gyms and must decide on the colors for their products. The possible colors are white, black, and violet. The payoff to each firm depends on the color it chooses and the color chosen by its rival, as the profit matrix shows. In Part A, given that the firms move simultaneously, identify any dominant strategies in this game and find any pure strategy Nash equilibria. The two players move simultaneously, so it is a static game. We write the payoff matrix and use the best response approach to find the pure strategy Nash equilibrium. The first number in each cell is Wrangler's profit, and the second number is Levi's profit. We first consider Wrangler's strategies. Given that Levi Strauss chooses white, Wrangler gets 10 if it chooses white, 30 if it chooses black, and 40 if it chooses violet. Wrangler's best response is to choose violet. We underline its payoff 40. Given that Levi Strauss chooses black, Wrangler's best response is to choose violet because it gives Wrangler the highest profit. We underline its profit 35. Given that Levi chooses violet, Wrangler's best response is white. We underline its profit 30. There is no dominant strategy for Wrangler. Next, we figure out Levi's strategy. Given that Wrangler chooses white, Levi gets 10 if it chooses white, 30 if it chooses black, and 40 if it chooses violet. Levi's best response is violet. We underline its profit 40. Given that Wrangler chooses black, Levi's best response is violet. We underline its payoff 35. Given that Wrangler chooses violet, Levi's best response is black. We underline its payoff 20. Levi does not have a dominant strategy either. We then circle the cells with two payoffs underlined. Those are the outcomes of the Nash equilibria. The pure strategy Nash equilibria are Wrangler chooses violet, Levi chooses black, and Wrangler chooses white, Levi chooses violet. In Part B, suppose the firms move sequentially, with Wrangler moving first. Draw a game tree and identify any subgame perfect Nash equilibria in this sequential move game. We draw the game tree for this sequential dynamic game. The profits for each firm are based on the payoff matrix in Part A. We use the backward induction approach to find the subgame perfect Nash equilibrium. There are two stages in the game. We first determine Levi's response in the second stage to each possible action by Wrangler. Given that Wrangler chooses white, Levi gets 10 if it chooses white, 30 if it chooses black, and 40 if it chooses violet. Levi's best response is violet. We underline its profit 40 and add an arrow on the path. Given that Wrangler chooses black, Levi's best response is violet because it gives the highest profit. We underline its profit 35 and add an arrow on the path. Given that regular chooses violet, Levi's best response is black. We underline its profit 20 and add an arrow on the path. Next, we figure out Wrangler's decision in the first stage, given Levi's responses. If Wrangler chooses white, it knows Levi will choose violet and it will earn 30. If Wrangler chooses black, it knows Levi will choose violet and it will earn 15. If Wrangler chooses violet, it knows Levi will choose black and it will earn 35. Wrangler is better off choosing violet. We underline its profit 35 and add an arrow on the path. The Subgame perfect Nash equilibrium is Wrangler chooses violet, Levi chooses violet if Wrangler chooses white, violet if black, and black if violet. Recall that a strategy is a plan that specifies a full set of actions conditional on its rival's possible actions. So, Levi's strategy in the dynamic game should be stated as above. The equilibrium path is that Wrangler first chooses violet and then Levi chooses black. The outcome of the game is that Wrangler gets 35 and Levi gets 20. Let's answer exercise 3.9. It is a sequential dynamic game between the incumbent and potential rival. The incumbent moves first. Suppose the incumbent does not invest. If its rival does not enter, it earns 0, and the incumbent earns 900. If the rival enters, it earns 300, and the incumbent earns 400. Alternatively, the incumbent invests. If the rival does not enter, it earns 0, and the incumbent earns 500. If the rival enters, the rival loses 36, and the incumbent makes 132. Show the game tree. Should the monopoly buy the machine anyway? It is a sequential dynamic game with 2 stages. The incumbent moves first. We draw the game tree according to the description in the exercise and use the backward induction approach to find the Subgame perfect Nash equilibrium. We first determine the potential rival's response in the second stage to each possible action by the incumbent. Given that the incumbent does not invest, its rival gets 0 if it does not enter the market, but 300 if it does. The best response is to enter the market. We underline the rival's profit of 300 and add an arrow on the path. Given that the incumbent invests, the rival's best response is to stay out of the market because it brings a higher payoff. We underline its payoff 0 and add an arrow on the path. Next, we figure out the incumbent's decision in the first stage, given its rival's responses. If the incumbent does not invest, it knows its rival will enter the market and it will earn 400. If it invests, it knows its rival will not enter and it will earn 500. The incumbent is better off investing. We underline its profit 500 and add an arrow on the path. The Subgame perfect Nash equilibrium is that the incumbent invests. The rival enters the market if the incumbent does not invest, but stays out of the market if the incumbent invests. Recall that a strategy is a plan that specifies a full set of actions conditional on the other player's possible actions. So, the rival strategy should be stated as above. The equilibrium path is that the incumbent first invests, and then its rival does not enter the market. The outcome of the game is that the incumbent gets 500 and the rival gets 0. The incumbent should buy the machine because it discourages the potential rival from entering the market. Without the rival, the incumbent earns 500, which is better than 400, the profit after the rival enters the market. The incumbent will never earn 900, facing potential rivals in the market. Let's go to exercise 3.10. Suppose that an incumbent can commit to producing a large quantity of output before the potential entrant decides whether to enter. The incumbent chooses whether to commit to producing a small quantity or a large quantity. The rival then decides whether to enter. If the incumbent commits to a small output level, and if the rival does not enter, the rival makes 0, and the incumbent makes 900. If it does enter, the rival makes 125, and the incumbent earns 450. If the incumbent commits to producing a large quantity, and the potential entrant stays out of the market, the potential entrant makes 0, and the incumbent makes 800. If the rival enters, the best the entrant can make is 0, the same amount it would earn if it didn't enter. But the incumbent earns only 400. Shows the game tree. What is the Subgame perfect Nash equilibrium? It is a sequential dynamic game with 2 stages. The incumbent moves first. We draw the game tree according to the description in the exercise and use the backward induction approach to find the subgame perfect Nash equilibrium. We first determine the potential rival's response in the second stage to each possible action by the incumbent. Given that the incumbent chooses the small output level, the potential entrant makes 0 if it does not enter, but 125 if it enters the market. Its best response is to enter the market. We underline its profit 125 and add an arrow on the path. Given that the incumbent chooses the large output level, the potential entrant earns 0 whether it enters the market or not. The potential entrant is indifferent between entering the market and staying out of the market. We underline its profit 0 and add arrows on the path. Next, we figure out the incumbent's decision in the first stage given the potential entrant's responses. If the incumbent chooses the small output level, it knows its rival will enter the market and it will earn 450. If the incumbent chooses a large output level, it knows that its rival will be indifferent between entering and not entering. So the incumbent's expected profit will be the average of 800 and 400, which is 600. The incumbent is better off choosing the large output level. We underline its profits and add an arrow on the path. The subgame perfect Nash equilibrium is the incumbent commits to the large output level. The potential entrant enters the market if the incumbent chooses the small output level, but is indifferent between entering and not entering if the incumbent commits to the large output level. Remember that the strategy is a plan that specifies a full set of actions conditional on its rival's actions. The potential entrant's strategy in the second stage should be stated as above. The equilibrium path is that the incumbent first commits to the large output level, and then the potential entrant enters the market or stays out of the market with equal probability. The outcome of the game is that the incumbent is expected to earn 600, and the potential entrant makes 0. A more realistic assumption is that the profit of the potential entrant is negative if it enters the market after the incumbent chooses a large output level. In that case, the equilibrium path will be the incumbent first commits to a large output level, and then the potential entrant does not enter the market. The incumbent earns 800 and the potential entrant makes 0. In other words, the incumbent moves first and commits to a large output level to discourage the potential entrant from entering the market. Thank you very much for watching this video and solving the exercises with me today. See you tomorrow. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.